Welcome to the second video on the ArduPilot Methodic Configurator series. On this one, I will explain you how to install the software, mission planner, and the firmware on the flight controller, then how to start the project, how to use the component editor window to enter component and connection information, and how to use the parameter editor and uploader window to change the parameters. To install the Methodic Configurator and the software that you are required to, head over to this URL here, scroll down, and press the Install ArduPilot Methodic Configurator. Now it opens here for Windows. Click on this link. It heads over to the GitHub webpage where you can see the release notes, and you scroll down to the assets and select the first asset. We ignore the others, they are not relevant for you. Press on it, it gets downloaded. And once it's done downloading, you can just select it to execute. Select more info, run anyway. As a language, you can select German, English, Italian, Portuguese, Japanese, and Chinese. Accept the license agreement. You want to create a desktop shortcut. These other two options are only for users that want to execute the Methodic Configurator from the command line. Most users don't need that, so leave them empty. Select Next, Install. We don't want to launch it right now, so you can deselect that. Go back to the installation page. And now you want to install the latest Mission Planner version. So you can click here, download and install Mission Planner. It heads over to the ArduPilot website. And then you can select the latest version, download it, click on it to execute, select yes. Next, I connected my computer to a CubePilot Cube Red, and I'm now starting Mission Planner. So I'll press Setup, install firmware, the Copter 4.5.7 official, that's the current latest version. So I'm going to install that one. I'm going to install in the Cube Red primary, and this is the firmware, and just press Upload Firmware. Now I'll just connect to it. And I'm going to the config, full parameter list, select reset to default. This is not required, but is very advised. You should start with the default parameter. It's the safest way to get the configuration correctly done. If you already have done some calibrations and you're sure that you didn't mess up the calibrations, then you can use that. But if you're unsure, if you messed up, just reset them to default and start over. So I'm going to reset to defaults. Port is resetted. I can now close Mission Planner. We started the software by double-clicking the desktop icon. The software will automatically open this web page on your browser so that you can see how to use the Methodic Configurator software for the first time. It has details on every single step. This menu pops up asking you where are the parameter files, because they are not found in the current working directory. You have three different options: create a new vehicle, open vehicle, or reopen vehicle. Right now, this is the only meaningful option for you. The software has context-aware tooltips for every single GUI element that it has. For instance, here, source template directory explains you what that is. Blank component data, infer, all of these elements have context-aware help that you can invoke every time just by moving your mouse over the desired element. We'll start by selecting the source template directory, pressing this little button here. And now it asks you to select the template that most resembles your own vehicle components. It doesn't have to match 100%, but the closer it is, the less work you're going to have. You can sort this by template path by clicking on it, or you can select by FC manufacturer so it gets sorted out, or model or any other column. And if you press twice, it gets sorted in the inverse order. We have here vehicles ranging from 500 kilos to 600 grams. The one that most resembles the one that I'm having right now is the Olibro. So I'm going to select that one here. The flight controller is different. My takeoff weight is different. My propeller diameter is different. All of these values are different, but it's the closest one that I have. So I will select it by double clicking it. Now, I'm not going to use any of these options here. I advise you also to not use any of them, to just leave the defaults, because if you already have a vehicle that is not flying correctly, it doesn't make sense for you to use parameter values of that vehicle. So it doesn't make sense for you to click this button. But if you have a vehicle that is already flying absolutely correctly and you're very, very happy with that vehicle, then click this button. Destination base directory is where you're going to create your files. So I'm going to create my files on the documents directory. I can click here to change that. And I need to give a name for my vehicle. That will be test vehicle 10. What this will do is copy all the configuration files from this directory into a new directory called test vehicle 10. That's a subdirectory of the documents. If the software is connected to your flight controller and that flight controller has documentation, then that documentation will automatically open in your browser in the background. In this case, I connected the PICSOC 4, so that's the page that we are seeing right now. And you can see all the information about that flight controller that's available to autopilot users. Now that we have our project files saved in the vehicle configuration directory, we're going to edit our vehicle components and the connections from those components to the flight controller. For that, we'll describe the properties of vehicle components. Each field has mouse over tooltips for guidance, just like on the previous window. Optional fields are marked with gray text and can be left blank. So we can dismiss this. We'll start by focusing on the non-optional parts of our vehicle. So the takeoff weight is 1.5 kilos and the maximum takeoff weight is also 1.5 kilos because this vehicle does not release any payload. I have here tooltips explaining what the frame is. I have tooltips explaining the specifications, what they are, and another tooltip explaining the element that I'm now using. We'll scroll down to the next non-optional parameter. That's the connection between the RC receiver. The connection is RC in our case, S-bus. I'm going to set the protocol to all. So any protocol that's coming in via the RC in or the S-bus input of your flight controller is going to get recognized. Next one is the telemetry. Telemetry is connected on my flight controller, also on serial 1, so I don't need to change that, but it's not Mavlink high latency, it's Mavlink 2. Next one is the battery monitor. It's also using an analog battery monitor and it's monitoring voltage and current, so we don't need to change that. The battery specifications, the chemistry, this is a LiPo battery, so it's correct. The voltages are also correct. Number of cells is also 4, and the capacity is also correct. I actually have a very different ESC. Let's see if that ESC is available on the template lists. Yes, it is. It's the FETEC 4-in-1 35 amps. So I will select that one. You will notice that the manufacturer has been inserted, the model, an URL, the version, everything is correct except the FC connection. It's actually connected to the serial 2, so I'll change that. I could change stuff here if I want to, like this version here. So all fields are still editable. If I want to save this as a new template, all I need to do is create plus and then give it a name, and I will have a new template. So for the motors, there are 14 poles as well. No need to change that. The propellers are 10.5 inches, so I'll enter that. And the receiver, we're actually using a here tree. I will select it. Connection is also correct, CAN and drone CAN. I have done all the configuration for the components that are mandatory. But I would really like to add all the information, even the optional information, because it helps the future me in a couple of months know what components are in my copter, helps somebody else that's reviewing the configuration of this copter, and in the future, the autopilot methodic configurator might start using that information and or feed that information to an AI to help you configure. If you're lazy and you do not input that information right now, later on you're probably going to regret it. So we'll do it correctly, we'll do it methodically. My frame, it's not an Olibro X500, is actually manufactured by EIV, and the model is a 3D printed. And there's no URL. The RC controller is not a FlySky. This is a Radiomaster T16S. So that's it. And for the transmitter, we're using also the Radiomaster internal one. The RC receiver, we are using the Radiomaster. Now you need to pay attention because once you select a new template, it might change your connection. So the connection is now wrong. You need to correct that as well. As a telemetry, we are using an RFD 868. It's not available here. What we're going to do is to add that information, RF design. The model is the RFD 868. Now entered all the information for the RF design modem, and I'm going to save the template, and I'm going to enter the RF design RF868 as a name for that template. So the next time that I want to use this same radio, I can just select it from the pop-down menu. Let's continue to the battery monitor. This is already correct. The battery is already correct. The ESC is already correct. The motors are not correct, so let's correct that. This is actually the correct motor model. And I do not have an URL. These are not high thrust and powerful motors. These are very tiny motors. I can save this as a template. Next time I will have them here together with my other motors. The propeller is wrong. It's actually from T-Motor. And it's 9.5 inches. Being methodical pays off. I found out that I had the wrong diameter set. If you enter wrong data, like for instance here, if you enter 4.5, it will detect that the data is invalid and mark it as red. You are supposed to give a cell low voltage that's actually below the maximum cell voltage. So you're supposed to put something here like 3.6. That is one example of a wrong configuration. One other example of invalid configuration is when you select the same serial port for two different peripherals, something like selecting for the ESC serial 1. If you do so, You'll be using serial 1 for the telemetry because it's selected above, and serial 1 here. Now, when you press Save Date and Start Configuration, it will tell you that you have a duplicate connection for the serial 1, and it will highlight it in red. So now you can correct that, test it again, and it worked this time. Now that we've entered all our information correctly, let's press Yes and continue the process. Now we've reached the parameter file editor and uploader window. This is the main window of the program. This is the window that allows you to actually change the parameters on the vehicle. The first time that it opens, it will tell you already if you want to skip some steps, because again, there are steps that are optional and steps that are mandatory. The first step, IMU temperature calibration, does reduce the number of SL inconsistent and gyro inconsistent errors, but it's optional. We are not going to skip it right now. I'm going to show you how to use that. So we're going to select No. Here is the usage pop-up for this window. You're supposed to read all the documentation on top of the parameter table. This is the parameter table. On top of it, there is documentation that we'll see. Next, you're supposed to edit the parameter new values and their change reason. That's the new values, that's this column here. You're supposed to edit them and their change reason that appears here. Documented the change reason is very important. First of all, it forces you to think, makes it easier for team members or AI tools to validate the parameter values, and preserves your reasoning for future reference or troubleshooting. Then there's the delete button to remove a parameter from this particular step, and the add button so that you can add parameters to this step. Now that you've read it, you can dismiss it. There is the vehicle configuration directory. That's the directory where you selected to create your project file. This is your directory where the project files reside. The current intermediate parameter file, we're going to see in a moment what that means, and the configuration sequence progress. Configuration is divided in phases, and each phase is further divided in steps. There are some phases, like this one, that are optional, and other phases that are not optional. They are marked here with the black text, and this one here. We are starting in the very beginning, IMU temperature calibration. The entire phase is optional and it consists of two steps. This is the first step. That step is defined in a file called 02 IMU temperature calibration setup parameter file. And for that file, there is documentation. You can click here to see the form blog for the documentation on that step. You can click here to see the wiki for that step. If there is an external tool that you're supposed to use, that external tool will appear here. It tells you that this step is not mandatory, it's not fully mandatory, it's recommended because the phase itself is optional. For the step itself, there's the parameter table here where a list of parameters is displayed with their respective names, and on the pop-ups you get to see the documentation for that particular parameter. So you get to see how you can use that parameter and what range it has, what's their default value. You see all that information here for every single parameter. On this column, you see the current value of that parameter in the flight controller. Here you set the new value that you want to change. See the units, and here you can select if you want to upload that to your flight controller or not, and then the change reason. When you set your mouse here, you will see why this step is to be performed. In this case, the IMU diff is temperature dependent and can cause gyro or SL inconsistent errors, and why this step is done right now and not after or before some other step. For the parameter table, there is also some legend explaining why some parameters are displayed in different colors. Normal parameters are displayed in gray background, like this one. Calibration parameters have a yellow background. You can see it here in the legend. It's also explained why it's in yellow. It's a calibration parameter, it's non-reusable. Even if you have a similar vehicle, you cannot copy this from one vehicle to the other. Read-only parameters are displayed in red background. Usually you don't see those in the tool because it doesn't make sense to change a read-only parameter. If a parameter has the default value, it will be presented with a blue background. And if the parameter is not available in the flight controller, it will be presented in orange. If the parameter is not editable because the tool knows the value for that parameter and you are not supposed to edit it, then it will present it in gray. Many parameters are presented in gray because you're not supposed to change it. They are already correct. Like the board heating target, for the purpose of testing the IMU temperature calibration, the board heating target should be 65. That's reasonable for most places on the earth, and it's correct for this particular step. At a later step, you can change that to any other value. But right now, for performing the IMU temperature calibration, this is the meaningful value for that parameter. So you're not supposed to edit it. And that saves the trouble for a lot of beginners because the software does that automatically for them. Now, if you don't agree with that value, click this button or declick it, and those parameter values are not going to be written to the flight controller. So you have full control over what gets written to your flight controller. Under the parameter list, there are more options. See only changed parameters. When you press, you get to see only the parameters that are going to change in the flight controller if you upload their values. Here you can see that every single parameter is actually going to change its value if you upload them. So none of them disappear. And the second option, annotate documentation into the parameter files, allows you to write the documentation for every parameter into the file itself. I don't recommend doing this because the files will be bigger. Next to it, there's the upload selected parameters to the flight controller and advance to the next configuration step. The last button is Keep Parameter File, allows you to save the changes that you have here to a file, but not upload it to the flight controller. The very last element is this one here. Press it to get this manual here. It has links to the user manual, to the support form, how to report a bug, the licenses of the software used, and the source code of the software itself. Now that we've seen how every single GUI element works, we are going to start editing the parameters of the flight controller. Board heating target, we don't want to change that because our board actually does not have the board heating target. We'll skip that one. We want to learn the calibration, so we want to set this to 2, so it's already correct. We don't need to do anything. The default target temperature here is 70 degrees. We're going to set that to 50, and we're going to set this value here also to 50. The PICSOC 4 from Holybro does not have a board heater, does not have that board heating target. So it will heat naturally to 50 degrees, but will not be controlled. We're done. We can now select upload to upload all these parameters to the flight controller and advance to the next parameter file, to the next step. It asks you if you want to write the changes to the parameter file. So to write the changes to the hard disk of your computer, you should answer yes. It will then proceed to upload the parameters to the flight controller. So it will change this parameter from 1 to 2. It will change this parameter from 45 to 50. It will change this parameter again from 1 to 2, and this 36 to 50, this 0 to 2, and then it will download them to make sure that all the parameters have the correct value. Now it asks if you want to proceed for the next step, but for the next step, you need to put the board into the refrigerator. So cannot proceed right now. So we're going to say no, I don't want to proceed. It then opens automatically the documentation for the next step. You should read and follow the documentation. That's it for this video. On the next video, I will discuss how to use the Methodic Configurator software after having created the vehicle from a template. So how to use the Methodic Configurator for the second time. This use case here explains you exactly how to do that step by step. It's very similar to the procedure that we just finished. We are going to load the files instead of select them from template and stuff like that. So see you in the next video.